let's take a look at percentage change problems. It's quite common to be wanting to figure out how to increase or decrease a quantity by some percentage of its original total. Now you might already know a formula that can help you do this, but let's look at developing that formula with some conceptual understanding behind it. In the diagram we've got here, we can see that 1% of a total is equal to 1/100th of the total. So we're looking at 100% and 1%. We know that to get from 100% to 1%, we need to divide by 100, or conversely, from 1% to 100, we need to multiply by 100. 1% of the total is 1/100th of the total. That's the meaning of percentage, really. We might also think of this as the total divided by 100. Now we can use this fundamental idea of percentages to help us with percentage increase and decrease problems. For example, if we want to increase a quantity by 1%, we need to find 1% of that quantity and then add it. Pretty simple, right? Divide the quantity by 100, that gives you the 1%, and then add that result onto what you started with. Similarly, if we want to increase by 10%, we just find 10% of that total and then add it. 50%, 60, whatever the percentage really. It all works the same way. Let's check out a couple of examples to see how it works. In the first example on the left, we're going to increase the quantity 400 by 12%. So let's look at it using a dual scale number line. We have in yellow 0%, 1% and 100%, and in red the 12% that we want to increase by. What we're going to do here is note that 0% of 400, well of course that's 0, and 100% of it, that's 400 itself. That's the total. Now to get 12%, what we're going to do is note that 1% is found by dividing the total by 100, and then 12% is calculated from there by multiplying that 1% by 12. We'll do exactly the same things because it's a proportional relationship. On the right side of our number line, we'll divide our 400 by 100, and that'll give us the 1% equivalent, and then we'll multiply that result by 12 to get 12%. Once we know what 12% of 400 is, we can simply add it on to the 400 itself. So we have 400 divided by 100. That's of course equal to 4. That's our 1%. Now 4 multiplied by 12, which is 48, that gives us our 12%. So that's 12% of our total. So to increase 400 by 12%, we're going to have 400 plus 48 is equal to 448. So there we have an increase of 12%, 48, on our original total 400 gives us 448. The next example on the right, we see that we're going to decrease, this time 80, the total, by 6%. I've started off the dual scale number line myself, but why don't you pause the video now and have a go at this one. See if you can decrease 80 by 6%. Come back in a couple of minutes and I'll run through it. So again, we're going to use our dual scale number line. Our total is 80, so that's 100%. 0% of course is 0. To get to 1% of 80, looking at the percentage side of the number line, we need to divide by 100 to get down to 1%, and then we need to multiply by 6 to get our 6%. So we'll do the same over on the right side of the number line. We want to divide by 100 to get 1% of 80, and then multiply by 6 to get 6% of 80. So we should have 80 divided by 100, which is 0.8, that's our 1%, and then 0.8 times 6, which is 4.8, that'll be our 6% of the total of 80. So to decrease 80 by 6%, we need the original total of 80 minus, because we're decreasing, 4.8, and that should give us 75.2. So that's the decrease of 6% from 80, 75.2. Let's look at it in a slightly different way. At the top here, we've got what looks like the start of another dual scale number line. And the interesting total here is that we've got 112% at the top. Now what I'm trying to represent here is an increase of 12%. An increase of 12% on the original total would give us 112% of that total. Now, thinking dual scale wise, if we want to get from 100% down to 1%, we'd divide by 100. And then to get back up to that 112% to give us the increase of 12%, we multiply by 112. So if we want to think about a slightly different way of doing the increase percentage, an increase of 12%, we divide by 100 and then multiply by 112. At the bottom, we've got another dual scale number line coming along. Here we can see the interesting total, or the interesting amount, is the 83%. Now what I'm trying to show here is a decrease, not of 83%, but of 17%. So if I decrease my original total by 17%, I'm looking at going down to 1% to figure out what that is, divide by 100, and then back up to 83, so I'll be multiplying by 83. Now that one's just a little bit weird because you've got to think about those two numbers there, 83 and 17, which of course come together to make 100%. So that's just another little way to think about these percentage increase and decrease problems. Now the neat thing about that is that they start to push us towards a general formula, which we'll look at on the next slide. After a while, doing all these dual scale number lines can get a little bit tedious, and really we want to push our students, or ourselves, away from having to go through that whole process, and of course moving towards the fluency of using a formula. And the formula of course represents the conceptual ideas underneath it. So we can start to generalize things. What I've got here is two examples where we're going to decrease by not a specific percentage, but X%, and an increase, again, by some general value or arbitrary value of X%. But of course it all works in the same way. If I want to get from 100% down to 1%, I'm going to divide by 100. Coming back up to figure out what X% is, I'm going to multiply by X. So we then have that X% of the total is X over 100 multiplied by the total. Now putting that all together, we'd find that to decrease our total by X%, we're going to have the total minus X over 100 times the total. And we can do a little factorizing there, and we'll see that it's 1 minus X over 100 multiplied by the original total. So that's the formula, I guess, for decreasing a total by X%. We have the one lot of the total, take away X over 100, or X% of the total. Now we can do a very similar thing over on the right hand side to increase by X%. Of course we're going to go down, divide by 100, up, multiply by X. So X%, again, it's the same. X% is X over 100 times the total. And then to increase our total by X%, we have our total, this time plus because it's an increase, X over 100 times the total. And again, factorizing there, we'll have 1 plus this time, X over 100 times the total. So there's our result for a general formula to increase some quantity or total by X%. So there we go, a bit about increase and decrease percentage problems. We've gone through it, looking at it conceptually, looking at it in terms of this dual scale number line idea, figuring out what X% is, or a specific percentage, bringing that up to decrease or increase a total by some percentage, and finally coming through to these results on this slide where we can look at a general formula for increasing or decreasing by some percentage.